This is an internal use case. And this is something we wanted to do to give you some feedback of Squore usage internally. And this is what we did. And we tried to organize a presentation and to discuss about the OKR, which means objectives and key results. And I'm going to describe this on the introduction slides. So I would just give some feedback about the use case in order to explain what we are talking about. And I will then show the result and assessment that we've reached using the product for 1 year. And then we will have a short conclusion. And I hope that you may have some question at the end. So the objective of this session is to show a pragmatical approach of a Squore use case on a real project. And side objective would be to show that actually vector teams are actually using Squore. We use Squore inside continuous integration framework on a daily basis to address quality. And we use Squore to implement OKR, which are objective and key results. And I'm just going to explain what it is. You probably know KPIs, so key performance indicators, which is a way to represent the data on the scales in a graphical way or in a metric way. The idea is to have a way to understand and easily understand the meaning of a metric. So behind this D rating that everybody can understand, it's not very good, it's not very bad, it's in the middle. But behind this interpretation, there might be a technical matrix that not everybody could understand. So the key performance indicators are here to ease the interpretation of the data. And because it's easy to understand, we can take actions. But in reality, we would need more objective and key results as an assessment. So in that project, we decided to have an overall objective, which is having a useful and maintainable product. And the way we want to reach this objective is to implement the key results, which are the following: having a stabilized technical depth, making sure that all complex modules are properly tested. Also implement all critical requirements and make sure that they are well tested as well. And we want a perfect control of the process. And so this objective and key result are a little bit more high level than a list of KPIs, but the KPIs will be the data that we will use to evaluate the key results. And this is what I'm going to explain and how we did that in the project. So let's have a more context of this project. So we're talking about the PyScore project. It was actually initially raised by a customer request who wanted to have a layer, a Python layer on the REST API of Squore to ease the creation of reports in Excel. It was the initial request, and we actually had some other internal use cases that we wanted to implement as well. And so we have extended these Python libraries to cover different things, like having a plugin for continuous quality gates in Jenkins, and also having a complete framework for building tests for the configuration of the product. So this project is used by some customers. It's used also by some Squore experts, and we basically use this framework to validate the configuration upgrade during a new delivery of the product. This is not really important exactly what it does. What is important is that this is a real project, a small one, around 5,000 lines of codes. But we tried to have a clear process of development around this product as you would have in your context. So let's see what we have in this tool chain. We, of course, have a version control system. We apply static code analysis as you are doing. It's a Python project, so we are using PyLint and Squore analyzers. So we don't have any Mistral checker for this context of Python. We do have unit test using PyUnit test framework, and we import in Squore the statement code coverage and the test verdicts. We use a homemade framework for the integration test, and this framework allows us to create scenarios that covers the requirement inputs. And these requirements are defined in Excel, so it's not a perfect tool for requirement, but it's very flexible and largely enough for the needs of this small project. However, in this Excel sheets, we actually manage the criticality of the components of the requirements, which is close to the ASIL, and we also have the full traceability between the requirement and the different tests. And all of this is integrated into a Jenkins pipeline using the Blue Ocean plugin. And we, of course, use the Squore quality gates to evaluate the quality and take actions on the development. So how does it work? We use the Squore KPIs to evaluate the quality, and we use that inside the quality gates. So basically, every time we do a code change, we trigger a new build. The complete toolchain is applied. Then Squore evaluates the KPIs, and we rely on the quality gates to evaluate these KPIs to accept or to reject the build. If the gate is passed, Squore will perform a baseline, and so the result in Squore will be saved. The meaning of this is that we can deliver the product to the customer. If the gate is not passed, Squore will keep the version in the draft versions, and so the next run will overload the current result. And the meaning of that is that the delivery cannot be done to the customer. This looks like this. We can see at the beginning of the pipeline the list of the different tools that we have. Then we apply Squore for building the KPIs, and then we enter the quality gate phase where we have a lot of different gates. I'm going to describe this. And then we have the baseline in Squore. The baseline is performed if all gates are passed, and then we can create a report or simply deliver the product to the customer. So just one question here, who would be interested by this continuous quality gates? We can see that we have some gates that could be related to the code issues, like no new findings or no duplications. So clearly this gate will target the developer use case. And we also have some gates where we want to be sure that we have a test on new functions or that we have tests on legacy code or complex code. And so clearly, in this case, the targeted user will be the testers. In our case, we were in a small team, and so we all have these two profile of developers and testers, but these clearly have different objectives. So let's have a look at these different quality gates in detail. We have three big pillars, and so we must pass the first pillars before going to the second one. The first pillars is addressing the process quality gate. So here the objectives is to make sure that people are working properly in regard to the coding guidelines, to the process, the maturity that we want to reach. And so we have two gates. The first one is to make sure that the coders are actually respecting the guidelines. So everything which is new, we don't care about the legacy, but everything which is new should be perfect in terms of coding rules. In the same way, every new function should have its own test, and even if it's a small functions. So we just want to make sure that starting from now, when we pass this pillar of quality gates, the team is ready to address the quality topics. So the second part of this quality gates regard the product quality gates. So here we just want to make sure that the quality is good enough for maintainability purposes. So we want to remove all duplication and clonings to make sure the design is sustainable. And we also want to remove blocker and critical issues just to make sure that we have a break prevention strategy in place. Once we have done that, we can have a look at the testability of the code. The code is now cleaned enough to be tested properly. So we can now address the legacy part of the project because the new code should be handled by this gate, but the old code should be handled by this quality gate. So here, we don't have time to test everything, so we will just use Squore to focus on the complex part of the code and make sure that we have enough tests on these functions. We also have a second level which intends to address the very complex functions. So the functions which are very big and very complex, and we want to make sure that we have a good coverage of this function, just to say that the heart of the product is really reliable. The third level here is more like using the traceability analysis from the product with the links between the code and the test and the requirement, and just to make sure that everything which is implemented in the product actually serves the requirements. So we don't want to be in the case where developers had a new features, even if it's not asked by anybody, and because it's very important to have this full traceability. So this is clearly something that we wanted to handle as well. So let's have a look at the result and assessment that we've done. So just to give you an idea, the project started a little bit more than 1 year ago, and it looks like this after the first week. We can say it was a very difficult but exciting start. Difficult because we can see this capture from Jenkins from 1 year ago. All the build were actually almost failing at every time because the gate was not passed, or because the whole tool chain was not working properly. So it was difficult to actually keep the motivation here to pass these different gates. But the side effect of this was a clear improvement of the overall quality. So in a few weeks, we've been from E to C rating, and this was really a good motivation for the team, because we were actually getting the feeling that the quality was there and that we were reaching a good quality product. I'm not talking only about the coding part. I mean, this is also here we can see the trend of the test. So we clearly worked on the test, on the coding guidelines, on the comment of the codes. All aspects were actually tracked with this score. So this was really something that I wanted to share, is that it's not especially easy to start a very good mature quality process, but it's really worth to do it. If we look at the overall trend for this year of development, we clearly distinguish 3 stages, and the 3 stages were actually expected, and they were completely in line with the different quality gates that we have implemented. So the first gate, as we said, we wanted the new code to be very good, and we wanted a good process around the new code with the new test and so on. And clearly, after passing these gates, the coders were had the good skills to work on the product. So we knew that everybody was respecting the guidelines, and that everybody was adding the test when they were adding a new code. So that was really something very good. We were in a kind of confidence feelings around the development. So clearly it was a difficult stage gate to pass, but a very good one. The second part was much more easy to pass, actually, because it was really more focusing on issues to fix. And so if you have the time to do it, it's not very difficult to do it. And the side effect of this is that we had the feeling that the product was much more maintainable, because we didn't have any cloning or duplications, and no big issue were actually stored in the product. So that was a kind of good feeling of having this sustainable maintenance states. The third big steps was directly linked to the reliability quality gate. So here we had the feeling of we say that the delivery became more safe and robust. I think it would be more true to say that we had the feeling of having of reliability in the product. We didn't find any big bugs in the tools, because all were handled by the test before, and so that was something that was really important for the teams to reach. So in terms of good feeling around the developments. So these are the 3 big benefits of having implemented these quality gates. If we now look at every big part of the project after 1 year, we can see here the trend of the test. So it's still going up after 1 year. So it's not just the initial phases where we increase a lot of tests. Then it's true that it was a little bit flat, but we are going up, adding more tests, and if we just look at the test of the past, the trend of the past test, we can see that it is going up. So yeah, there's still activities around the test, and so this is something which is important. If we look at the code, I wanted to have a deeper look at the technical debt, and especially because we have this technical debt quality gates. And so we wanted something to be more or less under control. No, we wanted to be something under control. And we state that it was more or less under control. And this is the explanation. This trend shows the new technical debt. So the first values shows the initial starting. So we introduced a lot of debt for the first version. We don't really care about that. But then we expect it to have a flat trend over 0. And we can see that we have some some disturb point here. And after analyzing what happened in these two versions, we actually realized that we did some manual baseline. What does it mean? It means that we manually accepted the quality of the build beside the quality gates outputs. And we did that probably for the bad reason, but we did it for delivering people. And it is just showing weaknesses in the process, and I will go back to that later. If we look at the fixed technical debt, we were surprised of seeing this. Actually, we expected something like this, a huge value of fixed technical debt. And we expected this because we knew that we had a product quality gates that asked the team to fix the critical and blocker issue. And this is clearly something that we can find out in Squore. This work has been involved by the quality gates. But then here we have two other fixed values, which were quite difficult to understand. And we looked at the result in Squore, and we actually realized that here we actually fixed some minor issues, which are completely outside the quality gates. And what is very interesting here is that because we have put in place a continuous quality process, we realized that it happens that the teams directly address the quality even if they are not asked to. And so this is very interesting to see the benefits of such a maturity process. If we look at the rest of the code indicators, so we have the rule compliance, which is, let's say, rather good. And the density of issues is quite good. I mean, it's almost all blue, meaning that we don't have a lot of issues in some functions. We may have some issues gently spread out in the different piece of codes, but we don't have a part of the code where we have all the issues and the rest where we have nothing. So this is a quite good distribution of issues. And the code is, let's say, more or less well described. This indicators is actually a mix between the complexity and the comment ratio. I invite you to have a more information on these indicators in the documentation of the software analytics handbook. But this means that the comment is rather good, and actually a third guy is introduced. I mean, participated to the developments of this product, and after some months, and he didn't had any issues to start working on the product and to start committing to the product. And I think this is one of the reasons why it was easy for him. If we look at the requirements, yeah, this is not perfect. Clearly, they are not all fully tracked and tested. This test readiness trend shows the trend of requirements which are linked to a test. And we can see that we have about 60% of requirements where we have at least one test which is related to, but some of them are not linked to any test, or maybe they are not implemented, or maybe they are just simply not linked to any test. So this is clearly not a good thing. This is something a way of improvement for us. And if we look at the test coverage trend, the value that we have here is very close to that one, which means that all requirements are actually properly tested. This is more or less what it says. But as a matter of fact, we are not really well rated for the requirements. On less than 60% are actually covered, which is not good. So we used another graphic in Squore to break down these requirements according the criticality. So let's say the ASIL. And what we did realize is that for the critical requirements, so the level D requirements, almost all of them are actually properly tested. And so this was a kind of a good way to to be optimistic around these developments, beside the fact that we still have some improvement to do. On the process, we wanted something to be perfectly handled. So first, the fact to have this continuous integration in place is a good sample of maturity. But we also use the review mechanism in the tools. And the first one that we used was the justification of the test failure. So we can overload the test result in Squore. And this overloading is really useful. I mean, we don't do that to improve the rating, even if it does. We just do that to avoid being polluted by wrong or irrelevant results from different tools. In our case, we had some tests that were always failing due to bad reason. I don't want to enter in detail right now. So we had to justify them. And what is really nice is that Squore can track the overloads through the different versions. And so this is really, really nice to get this. So using this overload mechanism is a good way to get confidence in the report that we are looking at. Here, we know that the red parts which are here only concern the real rate of the tests which are failing. And of course, we did that for the findings. This is more classical approach, but it's still very efficient. So Squore stored and track all the justifications from version to versions. And we also used the suspicion detection from the product. So here is a sample of what it means. When you start to justify your findings, Squore is able to track your findings even after the code change. And what happens is that if you modify your code below, just before your justification, Squore can raise these suspicious states to say, be careful, your justification may not be relevant anymore because your code has changed. So it would be interesting to review it and to accept it again, or to maybe to unjustify the findings. And this feature is really, really nice, and it really helps us to be confident in the findings review that we have put in place. So this is really a good feedback that we wanted to share as well. On a conclusion, we wanted to evaluate the efficiency of the quality gates. We started 1 year ago by stating that it's wonderful, it's great, and so on. But actually wanted to go deeper in that evaluations. So we analyzed the trend of the code and the trend of the technical depth. So we use these two graphics also coming from Squore. This graphic shows the trend of the codes. So in gray and blue, we have the legacy codes. I mean, all the code that were inside the project at the beginning. And in purple, we have all the new codes that we have added in the project. So here we can see that we have added 42% of new files. If we weight this trend according to technical depth, we can see here that we have introduced only 28% of technical depth, which clearly means that the new code is much better code in terms of technical depth. So this is good, and in that way, the quality gate is efficient. But we still have 28% of technical debt, which is not supposed to be, which is not zero, what it was supposed to be. And so we have explanation for that. As I said before, we did some manual baseline, and when we did that, we actually accepted a lot of new debt in the product, which became a little bit legacy after a few versions. So this is clearly a bad practices. We can see this manual baseline here and here. So we have a huge increase of the depth. And so that's really nice also to see, to look at the graphic and to understand what happened and what was the impact of the decision that we made. Because when we made this manual baseline, we didn't realize this effect. The other thing that we also realize is that we, in our quality gates, we do not track the complexity-based technical depth, which means that everything due to the cloning or everything due to the static code analysis is perfectly under control, but we didn't realize that we didn't evaluate the complexity of the codes regarding the technical depth, and that was clearly a weaknesses in our quality gates. So what to do now? we have evaluated the weaknesses, so derogation are clearly not a good practices, and we must improve our quality gates. And this is something that we should always do. If we keep in mind that we started this presentation by stating that we wanted to have an objective and key result, so we realized that the gates really help to address this objective and the key result, but it's important to always adjust them and to evaluate and continuously improve ourselves and our process. So we did this exercise to evaluate if it was good or not good. Here is the status that we did, not really important about the fact that we agreed on if it's green or yellow. The thing is that this was the first milestone. The second milestone will be a second objective and a second set of key results. So the objective will be the same because, yeah, it's not perfect yet. And for the key result too, we will keep the first key result, all the different objectives that we had here, and we will also add a new result focus on the complexity technical depth, and here we would like to reduce that depth. So let's see just in a few minutes in the tool what we have. So this is a PyScore project. Here we have a version which is not stored. This is still the current version. We mean that the gate didn't pass. This is true. The last gate actually failed on the first one, which is no new findings. So we can just simply use the product to find and locate these new findings. And I will just highlight what Flavian did show to you before. Using the filter new findings, we have 2 new findings. We can start the review. And here we will see the code. Let me just reduce the code, expanded code. So we have these 2 findings. Here I've got a call to the exit function, which is not good. If I go to the second one, it is actually located in the same code. So I use the print, it's not good. I can compare that with the previous versions, and I can see that actually all these 2 issues are actually in line with a new piece of code that I actually added to the script. This is not a good practice, but we don't really care about these 2 findings. This is not really important. What is important is that in 2 clicks, I quickly found the 2 issues that actually are interesting to me in my process. So we should fix that. Just some other feedback regarding the different graphics. So here we can see the test trend that we have used in the presentation. We have in the requirement coverage the view which is more focused on the requirements. So here we can have this table where we can see the distribution according to the different criticality. We have the technical depth dashboard where we can see the density of issues, or we can see also the table for technical depth where we actually extracted the picture where we can see the new depth or the fixed depth. So all these graphics that I've shown in the presentation are actually exported from Squore. And the last dashboard that I would like to show you is the trend analysis, where we can see these 2 graphics that we have used in the presentation as well. And there is one which is here regarding the complexity of the codes. So here we have a graphic which distributes all modules. So all bullets are actually a function, and we can see in this view in the red zone that are all the function where the complexity is not good. I mean, too bad. And where do we introduce some technical depth? If we removed all the legacy codes from this graphic, we can see here that we have the 2 functions which are in the red zone. And these 2 functions actually are the reason for the complexity technical depth that we have found in our project. So clearly, we need to create a highlight for this to make sure that this will not this will not happen again in our continuous integration.